Okay, dear students, now let's proceed to another question. So again, here we are going to apply the principle of mathematical induction. Again, in order to grasp the main idea of this principle of mathematical induction, we need to do different exercises as much as possible. Now here it says you have been given that 2 is a factor of n squared plus 7n. See, it says 2 is a factor of n squared plus 7n. Even though it's not written here, you see, natural numbers are going to be considered because in the case of principle of mathematical induction, we are supposed to apply a set of natural numbers, okay? So what we need to do, as usual, is we have to call this as p of a certain variable. But now, you see, this is written in terms of n, so we can call this as p of n. Mind you, if this is written in terms of k or p or something like that, we might use p of, you see, the variable we are having here. So now call this to be like p of n. 2 is a factor of n squared plus 7n. Dear students, look, let's substitute 1 in place of n and see what's going to happen. 1 squared is 1 and 7 times 1 is 7 and 1 plus 7 makes 8. Do you agree with this? 2 is a factor of 8? Yes. What if I take number 2? 2 squared makes 4, and here 7 times 2 is what? 14. 14 plus 4 makes 18, and 2 is a factor of 18, it works. What if I take 10, for instance? This is going to be 100, and this is 70. So 100 plus 70 makes what? 170, and 2 is a factor of 170, it agrees. So look, we are unable to show the truthiness of this one just substituting every natural number in place of n. So whenever you encounter such kind of statements, you need to prove this one using a principle of mathematical induction. So, as I tried to explain earlier, what we need to do is we need to apply those 3 steps, okay? So here I start. The first step is to assure, the truthiness of this one for the first natural number. So look, p of n made this, so we directly substitute 1 in place of n, and it turns to be 2 is a factor of 1 squared plus 7 times 1, as you see. This is 8, so this is true, as you see. So as I tried to explain earlier, if this is true, guys, you need to proceed to the next step. What if this is false? If this is false, you must not go to the next steps, okay? Rather stop here and say that this is a false saying. But for the time being, we got this to be true, so let's come to step 2. Now look, in step 2, we need to assume that this statement is true up to a certain natural number k. Remember, student, I just tried to let you understand how this is true up to 10. For instance, if you take 10, we say 2 is a factor of 170. It works. What if I take 11, 12, 13, 14? Believe me, student, it would be true. So we are unable to show, the truthiness of this one directly substituting every natural number. So what we need to do is, we need to assume that this is true up to a certain natural number k. Just have that assumption. Now look, assume p of n is true for n equals k for some k element of natural number. Look, the set of natural number is infinite set. So if you are able to show that, this again is true for the next natural number k plus 1. Look, assuming that it holds true up to k, and if you are able to show that it is also true for the next natural number k plus 1, we can conclude that the statement holds true for every natural number. This is the way we need to show the truthiness of this statement. So step 2, we need to assume that p of n is true for n is equal to k. That is to say that, look here, that is to say that assume that this saying is true. P of k, 2 is a factor of k squared plus 7k is true. Assume that this is true. So our intention is to show that this is true for k plus 1 for the next natural number. That is to say 2 is a factor of, you need to substitute k plus 1 in place of k. Again, k plus 1 here. So if we are able to show that 2 is a factor of k plus 1 the whole square plus 7 into k plus 1, we can automatically conclude that this statement is true. So accept that for the time being 2 is a factor of k squared plus 7k. But beloved ones, what do you mean by saying 2 is a factor of k squared plus 7k? Look, we say that 2 is a factor of 6. Reason, because 6 can be written as 2 times 3, where 6 is a multiple of 2. If you were saying that 2 is a factor of k squared plus 7k, indirectly you are saying that k squared plus 7k is a multiple of 2. 2 is a factor of 8, written because 8 is a multiple of 2. We can write 2 as 8 as 2 times 4. The same is true here. If you are saying that 2 is a factor of k squared plus 7k, we can say that k squared plus 7k is a multiple of 2. So if that is so, we can have this k squared plus 7k equals 2 times m. You see, because we have assumed that 2 is a factor of k squared plus 7k in step 2. Assumption is taken. So for some sort of natural number n, k squared plus 7k is 2 times m. So beloved ones, you have to underline this, because in step 3 we are going to apply this into account. Now coming to step 3, we need to show that this p of n, the statement we are having here, is true for the next natural number k plus 1. So for that, what we need to do is we directly substitute k plus 1 in place of n. Guys, look, just put k plus 1 in place of n, and it turns to be 2 is a factor of k plus 1, the whole squared, plus 7 into k plus 1. You can see that over here. You see, we need to show that this is true. Look, guys, what is this expression? This expression is nothing, but it is k plus 1 of this expression. You see, you simply put k plus 1 in place of k, or you simply put k plus 1 in place of n. Look, our intention is to show that this is true for the next natural number k plus 1. So you simply put k plus 1 here, k plus 1 here. So k plus 1 the whole squared plus 7 into k plus 1 comes. So guys, if you are able to show that this is true, you are done. You can say that this is, you see, a true statement. The one written here is a true statement. But the question is, how are you able to show that this is a factor of 2? I mean, this 2 is a factor of this expression. Or how can you show that this is a multiple of 2? See, what you need to do is, if you are able to show that this is a multiple of 2, you see, we can consider that 2 is a factor of this. And for this, what you have to do is, guys, listen now carefully, please. What you need to do is start from this, you see, and try to have a certain assertion over here that can you see, express this expression here in step 2. Or try to write this expression in such a way that you can use, you see, this assumption over here. So for that, what you need to do is, you see, have this as it is. So look, k plus 1 the whole squared, 7 into k plus 1. So now what we need to do is try to express this as sum of k squared and 7k, because there you can use 2 times m, you see, 2 times m. That's why, you see, I wrote this expression as 2 times m. So look, k plus 1 the whole square makes k squared plus 2k plus 1, as you see. Look, k plus 1 the whole square is k squared, as can be shown here. It's going to be k squared plus 2k plus 1, but you do have here 7k plus 7, so here they are, 7k and 7 are written, but I intentionally, you see, brought 7k here, you see, over here, because it has been assumed that k squared plus 7k is a multiple of 2, so in place of k squared plus 7k, I can write 2 times m, because it's assumed to be a multiple of 2. So look, k squared plus 7k plus now 2k plus 8 comes, because 1 plus 7 makes 8. Now from this, what follows is k squared plus 7k plus 2 into k plus 4. Look guys, I intentionally have written this expression in terms of what? This yellow color. Reason, because k squared plus 7k is already, look here, assumed to be a multiple of 2. So in place of k squared plus 7k, or the yellow expression, I can write 2m. You see, students, I can write 2m. Then 2m plus 2 into k plus 4. Look, 2 is available here. Again, it appears here, so I can take 2 as a common out. So I can have 2 into m plus k plus 4. So look, guys, here, k is a certain natural number, m is a natural number, 4 is a natural number. Set of natural number is closed under the operation addition, so you do have now 2 times p, where p representing these 3 sums, okay? For some p an element of natural number. So what have you obtained eventually? Look, eventually what you obtained here is this expression is written as a multiple of 2. So this guarantees that, you see, this is a multiple of 2. Indirectly, you see, you look, 2 is a factor of this expression. You see, students, look, 2 is a factor of this expression. So this assures that p of k plus 1 is true. You see, p of k plus 1 is true. That is to say, this statement is true for n is equal to k plus 1. Now, beloved ones, look, According to principle of mathematical induction, we need to assure these three conditions. At the beginning, we need to check, you see, the trueness of P of what? The first number, you see, and that has been already obtained. It has been verified here, true. In the second step, we need to assume that works up to a certain what? Natural number K, and we need to take assumption, so here we took. And in third step, using the assumption obtained in step 2, we tried to show that this P of n is true for n is equal to k plus 1. Here we did so by the principle of mathematical induction, you see, because the principle says so. By the principle of mathematical induction, one can conclude that, you see, the statement that says 2 is a factor of n squared plus 7n is a true statement. So whatever you see natural number you may place in place of n, it could be 200 or 1 million, whatever the case. You see the result is a multiple of 2, or we can say that 2 is a factor of n squared plus 7n.